All right, so I'm just going to be going over how to do this question because a lot of people have been asking and they don't understand it. So first, what I like to do is just ignore the other part and just focus on one at a time. Uh, First thing, you list what they give you. You have KOH and you have HCN. And it says 0.6 mole of KOH in 1 liter, so that's just 0.6 molar. And then you also have 0.6 molar HCN. Now you look at the species you have and figure out which one dissolves in water or like dissociates completely. This right here is a weak acid, so it won't dissociate completely. Most of it would just be left as HCN. And this is a strong base, so it dissolves into K plus and OH minus. And now you just ignore the cation or anion attached to an acid or base because it's just going to be a spectator ion. So you just ignore this K plus right here. Then you look at what you have uh, as the other piece. So right now you have an OH minus, which is considered a strong base because it came from this strong base. And whenever you have a strong base, it reacts with an acid completely until completion. So you have this OH minus, which acts as a strong base, and you have this weak acid HCN. So this reacts to form water and CN minus, I believe. Yep. Okay. So after you do the equation and figure out what the reactants and products are, you gotta look at the concentrations of your reactants. So you have 0.6 molar OH minus because this OH minus came from KOH and you had 0.6 molar KOH. And then you have 0.6 molar HCN, which is just the weak acid from the beginning. So you look at your reactants and see which there's more of or which there's less of, or if they're the same. If they're the same, they both get used up equally. So like, I guess a bad analogy would be if you have 6 drops of blue paint and 6 drops of red paint. Pretend blue and red cancel each other out. I don't think they do, but just pretend. If you had 6 and 6, they cancel each other out because they're equal. So this gets completely used up and this gets completely used up. So these are not in your final solution. So what you're left with is, first you're left with the CN minus that got produced from this OH minus and the HCN. And then you also have your lone spectator ion from the beginning, which didn't do anything in the reaction. All right, so since this is a weak base and this is just an ion, this would be considered other, and that would be considered base. So right here, you'd put in Cn minus and K plus. All right, now for the second one. So again, you list what you have first. 0.096 moles of NaOH in 1 liter, which is just 0.096 molar. You also have HCN and you have NaCN. If you want, you can label these first, or if you just know that what they are, then you just go off which one dissociates and which one doesn't. So this is a strong base, this is a salt, and this is a weak acid. Only these two, the strong base and the salt, dissociate completely. So you're left with, hold on, let me just put the concentrations too. So you're left with Na plus, OH minus from NaOH, HCN just stays as HCN, and you also have Na plus from the salt, and then Cn minus from the salt. And now you look at which ion you have. Usually it's either an OH minus or an H plus. If there's an OH minus, it reacts with with an acid. If it's a H plus, it reacts with the base until completion. So right here you have an OH minus. Hold on. I'm getting ahead of myself. First you have to consider the spectator ions. Right here, this Na plus, it won't do anything in the equation because it's not an acid or a base, it's just an ion. Here too, this Na plus is just a spectator ion. So you really have two of the same spectator ions, so it's just Na plus. All right, and then you consider whether you have an H plus and OH minus. If it's H plus, you react it with a base until completion. If it's an OH minus, you react it with an acid until completion. Since there's an OH minus, you find an acid you have. So it's this weak acid right here. So this OH minus is going to react with this HCN until completion. And then it turns into H2O plus CN minus. And then you list the quantities of each. So this OH minus came from NaOH, which was 0.096 molar. And then you have HCN, which just came from the regular HCN, 1.3 molar. And then you consider which one gets used up, if any, since there's less of OH and there's more HCN, and this wants to go until completion. This OH minus completely gets used up, and then you're left with a bit of HCN, and then the produced water, and also CN minus. And I think water is left out because it's either a liquid or it's just neutral. So in the end, you end up with the HCN that was left over from this reaction with OH minus, the CN minus that was produced from this reaction with the HCN and OH minus, the CN minus from this salt right here, which I'm sure it does something in the equation, but you just pretend it doesn't because it makes it much simpler. Just these two are the same thing, so it's only one unique thing. So you have this HCN again, as it was left over from this reaction with HCN and OH minus. And then you have the CN minus that was produced. You just ignore the water that was produced, but you have the CN minus, the HCN, and the Na plus, and that's going to be the final answer because it's these three things in the solution. So Na plus is an ion, which is other. HCN is a weak acid, which is an acid. And CN minus is the conjugate base of HCN, which is going to be a base. And let me try that. Na plus HCN, CN minus. Whoops. And right here you had K plus and CN minus, I think. Yeah, CN minus. Oh, whoops, K plus is not an acid, it's an other. And that should be right.